6.2, 6.2, day 2, 6.2, day 2. Focusing on dividing, dividing, dividing. Now before we get into dividing, here's just the rule for multiplying. When you have the same index, you have to make sure they have the same index, and you're multiplying, you can multiply the two numbers together. It's the same thing that goes for dividing. Make sure you have the same index here, then you can combine them. You can write either a fraction two separate, or you could write two separate into one full fraction. However, when we're actually talking about dividing radicals, you will often hear you have to rationalize your denominator. Rationalize your denominator. And I will tell you exactly what that means. So first, rationalize the denominator. Rationalize the denominator means we don't want any types of roots in the bottom of a fraction. Denominator, bottom of a fraction. Now, just to tell you, this is a very simple problem that I'm going to be doing today. So yes, you might be like, oh, this doesn't seem that hard, or why would we have to do this? But when you get into much more complex problems, you will understand more in detail. But so here I want to simplify this. If you look at these, rationalize the denominator, get this out. The reason we do that is because we want to see if we can combine like terms. Right now, in your head, you might be looking at this, be like, yeah, I can definitely combine those. However, it would be the same thing if I did something like this, if you're looking at 0 over 7 plus 7. Well, yes, you can definitely combine those two numbers, but the process of actually combining them is going to be different. Now, when I look at the numbers over here on the left, the reason why we rationalize the denominator, so getting the root on the bottom, and I'm going to rationalize the denominator down here. So to rationalize the denominator, basically we don't want this root down here. Now this is a square root, so we're looking for pairs. So if we were looking for pairs, we could always simplify the root if we had a pair of 7s. So in order to make that pair of 7s, you have to multiply by square root 7. To not change the original fraction that we're dealt with, we have to multiply by square root 7 over square root 7. So it's the exact same thing on both top and bottom. So me rationalizing this first number is 3 square root 7 over square root 7 times square root 7 is going to be the square root of 49, or that is just equal to 7. So I could rewrite this first problem as 3/7 square root 7 plus 1 square root 7, because if there's no number, this is like a 1 here. Okay, so now if I actually add those two together, let's pick a different color. Now I can take my 3/7 plus 1/7. So this would be 3/7 and square root 7 on top. Plus, if this is a 1, that's the same thing as 7 square root 7 over 7, because 7 over 7 is 1. So I can combine these two like terms, and you'll get into more of this in 6.3. So 3 plus 7 is 10 square root 7 over 7. Because once both of these numbers are on the top of your fraction, then you can add these numbers just like normal, or these numbers just like normal. So that's why we rationalize the denominator. It is more so that we can see what numbers we can combine together by adding and subtracting. So this first one I'm dividing. First thing I always have to look at is my indexes. Are they the same? They sure are. If there's no number, remember it's always a 2. So I can rewrite this now as 18x to the 5th for 2x to the 3rd. And I want to simplify this inside the root first. So this becomes the square root. 18 divided by 2 is 9. And x to the 5th over x to the 3rd is x squared. Now in this problem, the square root of 9 is 3. The square root of x squared is x. This is where, though, you have to remember to put those absolute value signs, because we started off with an even and I ended with an odd. So you want to make sure that it was an even, or it's going to be a positive number. So this right here will be my final answer. So this next one, the indexes are the same, so I can rewrite this as the cubic root of 1/6(2y to the 5th, 3y squared. I can simplify this now. 162 divided by 3. So that's cubic root of 54, and x to the 5th over, or y to the 5th over y squared is y cubed. Now I'm not sure what numbers multiply to get 54, so what I'm going to do is do my factory. So this would be 9 times 6, 3 and 3, 3 and 2. So this is 3 cubed times 2 to the first. So now when I simplify this, my cubic root would give me 1 3 on the outside, 1 y on the outside, and I still have the square root of 2 because this 2 right here, did not have a group of 3, so that has to stay inside. So I started with an odd, ended with an odd, so that's all alright. So that would be my final answer. Try to do this one all by yourself. Charmin. So that's what your answer should have been. Again, once you get to this point, you have your prime factorization, you have everything simplified. If you want to check your work, what you have to do is whatever you took out, you take that exponent, multiply it by your index. So 1 times 3 is 3. That's what I had inside. I took out 1x here. 1 times 3 is 3. I had a total of 5, so that means 2 have to remain inside. And this would be my final answer. Again, when you start with an odd degree for an exponent, you kind of don't care about the absolute values. Again, try this one by yourself. So it'd be 5, so if I simplify my root first, because these indexes are the same, so I can do that. 50 divided by 2 is 25, x to the 6th divided by x to the 4th is x squared. Square root of 25 is 5, square root of x squared is just x. I started with the even, I'm ending with the odd, so you have to make sure to have your absolute values, so that would be your final answer. So remember that long spiel about rationalizing the denominator? Here's another way to look at it. If you want to read all this jazz and all that jazz, you can do so. But again, we rationalize the denominator so that's easier for us to look to see if we combined like terms. It's just more proper. Just like how if you didn't say the word "the" for the whole day, that's kind of improper. You just don't do it, people. So I'm rationalizing the denominator here. There's different ways that you can go about doing this. So everyone might have their own way. So first thing I want to do is, if there's division, I want to see it. Can I simplify that? I can't simplify this problem for dividing. But what I'm going to do is I'm going to rewrite the top as cubic root of 5x squared over the cubic root of, I'm actually going to rewrite this as 2 squared times 3. Because it's 4 times 3, which is, so it's prime factorization, y squared times z. Okay, this is all that's on the bottom. And we're taking the cubic root. The whole objective is trying to get rid of the root on bottom. We don't care about the cubic root on top. That's not really important to us. Now, you always want to look at your index. So first, actually, rewind. If you could simplify inside the root first, you should. In this problem, I can't. Maybe in the future one, I will be able to. We'll see. But I want to try to get, so all of these 4 numbers or variables simplify with this cubic root. So this index will help you decide what should I multiply by. So I'm going to multiply something. You always look at the bottom first. That's what we care about most. So I'm taking my cubic roots. It has to match the index of what's given. I take it term by term. Now remember, I need groups of 3 because my index here is 3. So I need groups of 3 in order for it to simplify with the root. So when I'm looking at my 2's, I already have 2 there. So I need 1 more to get to a group of 3. When I look at my 3's, I have 1 3. So I need 2 more 3's to get to a group of 3. When I look at my y's, I have 2 there. So I need 1 more y. When I look at my z's, I need 2 more z's. Okay, so this will help me so I can get a group of 3 out of each one of these. Now, whatever I do in bottom, I must repeat. I must do the exact same thing on top. So 3 squared, y, z squared. Now, if you trust yourself and do it right, you should just come up with the bottom of the fraction, whatever is inside that root. So when I'm doing this, I'm just going to focus on the bottom. Actually, I'm going to multiply this out on top. So these are cubic roots, so I can multiply them all together. This would be, if you want to leave it in prime factorization for now and then simplify, that's what I'm going to do. Again, there's multiple ways you can do these problems. So I have a 5 times 2 times 3 squared times y times z squared, and I still have an x squared up top also. On bottom, this was the cubic root. Now, when you're doing this, I have multiplied 2 squared times 2 would give me 2 to the third. 3 times 3 squared is 3 to the third. Y squared times y would give me y to the third. And z times z squared is z to the third. Again, for each one of these, I looked at the same bases and combined my exponents. So these, and these. Now I'll simplify them one more time here. On top, none of these have a group of 3. So none of these could simplify with my cubic root. So I'm actually going to take this number and multiply the whole thing together first. So 5 times 2 is 10. 10 times 9 would give me 90. So this is a cubic root of 90. And then I just like the alphabet order first. So it'd be x squared, y, z squared. That's what I have on top. And on bottom, all of these, anything that's cubed inside of a cubic root, those should all cancel. So all of these cancel out. So on bottom I have my 2 times 3 times y times z. Now, the more proper way to write that is your cubic root, 90x squared y z, that squared, that's a y, over 6yz. And that right there is my final answer. So again, first thing I would do here is see if I can simplify. I can actually simplify. This is the cubic root. 4 goes into 32 how many times? Let me think. 8 times. So I can have a 1 over 8. This is x to the fourth. Y z cubed. Now what I'm going to do is I'm going to do two things in one step. I'm going to split the top and bottom, both of them for a cubic root. So this is x to the fourth. This becomes cubic root. I'm going to write this in prime factorization. 2 cubed y z cubed. Now I'm going to simplify this fraction. Before I do anything else, I'm going to simplify each root, both top and bottom. So this is equal to, I can take one group of 3 out. So I can take 1x out. Cubic root, I'm left with 1x in. Again, if you want to check your work, this is the first power. 1 times your index, that's 3. And I still have 1 here, so that equals the 4. On bottom, this cube, 2 cubed, can be simplified with my cubic roots. Those two would cancel, so I'm just left with 2 on top. Can't do anything with that y, but this z is also cubed, so that could simplify. So this z can also come out. Now I'm just left with the cubic root of y. So I simplified. Now I have to rationalize my root. Now just be aware, sometimes, not always, like in this case, not always, but sometimes once you simplify, you can simplify your fraction on top and bottom, so you should always be aware of that. So I'm going to multiply. I'm only going to look at the bottom, because that's what we care. We care about the denominator. Cubic root. We have 1y, but because my index is 3, I need to have a group of 3. So that means I need 2 more y's in here. So whatever's on bottom has to be the exact same on top. If it's not the same, then you can't do that. So now I multiply both the top and bottom by cubic root of y squared. Moving on up to the east side. So now what do I have here? On top and multiplying across. Now whatever inside the root gets multiplied. So on top of my fraction, I still have this x, and then I have this cubic root of this 1x, and then I have y squared, because I'm multiplying by cubic root of y squared. On bottom, I have this 2 out front, I have this z out front, and then this is the cubic root, and this is y times y squared, so that's y cubed. Now again, if you did everything right, this should be able to simplify with your index. My very final answer would be x cubic root xy squared 2, and because I like the alphabet, that thing alphabet, 2yz. I like to have the y before the z. If you have the z before the y, same answer. And that's it. So you have 3 problems you should try here by yourself. This first one, you're going to have to rationalize the denominator. These second 2, you want to divide. So you could end up with the same answer as I do once you push pause, check your work, check the work that I will be doing in a minute, or else your process might be completely different, but the answer could still be the same, and that's fine. If your answer is the same as mine, go you. First one, rationalize the denominator. You should multiply by the cubic root of 5 squared times y. And then your final answer will be the cubic root of 175xy over, divide by 5 times y. Next one, you have to actually divide these out, so you could write it as one simple fraction. You could just simplify it here. You don't have to do this step. And then you would get cubic root of 3x. And finally, same type of thing. Write it as one fraction. 21 divided by 7 is 3. X to the 10th divided by x to the 5th is x to the 5th. And I can simplify this. Remember, if you want to check to make sure you did this right, you multiply whatever you took out times your index. So if there's no number, this is like a 2 here. So 2 times 2 is 4, and then you have 1 inside, so that's 5. So that should be the same as what you had before you simplified. One more slide here, because I'm going to pick a harder one to rationalize the denominator. Alright, so I try to pick up a hard one, but it might not be that hard. I know. But one thing when you're doing this, you can simplify a fraction just like how you simplify 5 over 10 is 1/2 throughout any time of the process. Remember, just because you might have do it in a different step doesn't mean your final answer is going to be different. So you should try to pause this and start doing it by yourself. Or just see what I do and see if you can do the rest. But you should try to attempt this by yourself. First thing when I look at this problem, I personally like to simplify as I'm going, so I can simplify this right here. And because these have the same index, I can already simplify this because they're both inside the root, and I can simplify that. So before I do anything, I'm going to simplify those 3 things. New one. So 3 over 6, that's the first thing I'm going to simplify. That would be the same thing as 1 over 2. This is the cubic root and the cubic root. You don't have to write it as one full root because it's the same thing. But 2 and 32 is the same thing as 1 over 16. So both dividing by 2. X to the 4th over x, leave me with x cubed on top. And I still have this y squared on bottom. Okay. Now again, there's multiple different ways you could do this. I personally always like to simplify my roots before I actually start rationalizing. So one thing I'm going to do is I'm going to rewrite the top equation. So like this 3 can simplify with that 3. So I can take out that x. That's just one lonely x. On bottom, I'm going to rewrite 16. That's the same thing as 2 to the 4th. So I can take out, there's this 2 out in front right here, times, I can take out 1, 2, because there's 4 right there, leaving me with the cubic root of 2y. So what I actually have here, before I actually did anything with rationalizing, I have x on top, and then on bottom, this becomes a 4, so that's 4, and then the cubic root of 2y squared. Sorry, I forgot that squared right here. So now I have to think, okay, what should I rationalize this by? What should I do so that to make them a groups of 3? Why groups of 3? Because that's my index right here. So the x still, or no, so I'm doing my cubic root. I have 1, 2 here, so I need 2 more 2, so that's 2 squared. I have 2 y's here, so I need 1 more y. Again, whenever you do on bottom, you have to do on top. So now you might be thinking, like, why did I even simplify way over here? Because you should always simplify your root. Because I could have simplified it at the beginning like I did, or simplified the end, and you should still come up with the same answer. So now on top, when I multiply across, I have this x on front, and then I have the cubic root of 2 squared is 4, and then I have a y. On bottom, I still have this 4 out in front, and then the cubic root of 2 cubed y cubed. Here's the thing, guys, if for some reason you feel so confident in your abilities to do this, or the more practice that you do this to make sure you're doing it right, you don't really have to do this step. You could just go to your last step, because this would be 4 times 2, because it's whatever numbers you have inside here. So then I also have my times y. And then my very, very final answer would be the cubic, or x in front, cubic root of 4y over 8y. Dun, 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 dun. Way to go, you. Have a great, awesome day, night, or two. Or morning, I guess you could be watching this morning. Hey, keep your head up, chin up, smile, be kind, rewind.